Okay, so as we can see here, we have a front view and an auxiliary view according to the question. Cutting plane AA, our view is on a 30-degree angle. They want a sectional top view, sectional right view, and then we will also do the, what do you call this thing? The true shape. Thank you. Okay, so if I am working on an angle that is already on a 30-degree angle, very easy. What you guys can do, if you don't know where your center point is and you don't know how to work with your protractor, okay, you can go and you can do a bisecting arc just to find your center for your circle. Okay, so there's my center for my hexagon. Remember, a hexagon is 6 equilateral triangles. And these are my points. The other thing that you can do is, I just want to get my other set square, just to show you that especially if it is on a angle like this, it's already on a 30, and remember, now, it might be on a 45. That is why I want to show you this. You can set your one set square and then put your 30-60 on top of that. Or you can take your protractor and we do our equation where we take 360 and divide it by the amount of sides, which gives us 60 degrees. So then I can see that this angle will be on a 60-degree angle. But that I should know. So what I'm going to do now is, you will see when I do this and I set my set square now to a 30-degree angle on this side, it lines up with those scribes that I just scribed. Do you see that? So there's my angle there. And then also here I can connect these points and it will be on a 30-degree angle. And then a 30-degree angle to the other side. And then these ones will be straight a 90-degree angle. Okay, so there is my auxiliary view, and then just to set my set square again, we're working on a 30-degree angle. So my XY will be on a 60-degree angle. Do my projection. And this one is easy, even if you work with a pyramid, you just get a starting point away from your XY, so you'll basically always do the midpoint, and then you measure your distance. So it is 52. Set my compass on 52. On any one of the sides, scribe 52. Close off my front view. Then I will measure my distances for my cutting plane, which is 26. So 26 on here and 11 this way, so that gives me my space where my cutting plane goes through. And remember, a cutting plane is actually a B type of line, and it is a center line. And then just here on the corners, you'll do a very darker point, and you will label it. Don't forget this, because you guys are going to get a mark for your cutting plane, okay? So you have to do this properly. Now, I want a top view. Now I'm not worried about the angle that my view is on. Okay, so I'm going to do a top view on a 0-degree XY axis. So X, Y. And then I'm going to project my corners all down. Just want to switch this around. So first do 1/2. Okay, so why I'm saying first do 1/2, okay, I just want a number. 1, 2, 3, 4, 5, 6. Here we have 3 and 4, 2 and 5, 1 and 6. And remember, it's the same at the bottom. Okay, so we're going to start at 1. And now 1 and 3 aligns, okay? So I can go and scribe both of them directly. 1 and 3. And you can go and you can number them as well. 2. So there's 2. 2, 6 and 4 aligns. So I will do them the same. So when I say that it aligns, remember they are the same distance away from my x, y axis. And then I will do 5 lastly. So this is 6, this is 4, this is 5. Okay, so now in construction you connect your lines in construction, not in solid lines, because we still have to see where the cut will be. So everything always in construction. Now, why I said you don't have to go and project or don't have to go and do the rule of similarity twice is because now I can go and I can project these points down. And what I can do is, okay, so now this is 3 and 4. So this line, so that line's also 3 and 4. So I can go and connect 3 and 4. So 4, that's 3. Then this line here is also 2 and 5. So 2 and 5, there's 2, there's 5, and then 1 and 6 goes there. So this is now 1 and 6. And then I will go and draw this also in construction. Now I have my full view in construction. I just then also need to see what will be hidden detail, what won't be. But we're not looking at that yet. We're only doing that once we know where the cut is. So now if you're uncertain of where your cutting plane will cut your solid, what you do is you will project your cutting plane to your auxiliary view. So this there, and this one goes there. So now I can see that here it will cut my solid right there between 5 and 6 and 2 and 1. Okay, so when I project it down, it must cut between 1 and 2 and 5 and 6. Here it cuts on line 2, 2 and on line 5, 5. So 2, 2, 5, 5, front and back. Here also on line 3, 3, on line 4, 4, because I can see that it goes here on the line, okay? Whereas here it is actually at the top of my solid. So projecting my cutting plane down, here I know now that it cuts, sorry, that's skew, that it cuts on 1 and 2 and 5 and 6, on line 2, 2 and 5, 5 here, and then right here on line 3, 3 and 4, 4. Okay, so that is my cut. Okay, sorry, this one I made it the wrong place. So there, solid now, dark lines, connecting the dots. Okay, so that's my cut. Now I want to see what will I keep, what will I throw away? So you cover up the piece that's closest to you. Remember, we're looking at the top view, so this is closest to me, this that I covered now. So I will see this part here, line 1 and 6. So from the cut to line 1, obviously 1 and 6 is connected, and then 6 to the cut. Then I can see from the cut to the bottom here of line 2 and 5. So I just want to make sure that you guys know what I'm talking about. So from the cut to line 2 and 5. So from the cut to line, or point 2. From the cut to point 5. Then I'm looking at it from the top. So actually 1 and 6 is now hidden by line 2 and 5 here, because it's wider, okay? So then I will be able to see from 2 to 3, because now from 2 it goes up to 3. And then there. Then I want you guys to start showing hidden detail. So hidden detail will now be from 2 to 1, 1 to 6, and 6 to 5, as well as this very tiny little piece here of 1. We do not show hidden detail in the cut, okay? So in the cuts we don't show hidden detail. Then I will hatch on a 45-degree angle. So I will hatch into my drawing. So I'm going to set my lines on a starting point, then set the line that I just drew on those centimeter lines. Okay, and there is my cut. Okay, so now I want to do the true shape. Okay, I need to go and do the true shape of this drawing. I know they ask now for a sectional right view, but it will basically look exactly the same because you're looking from the right hand side. So it will be exactly this view, just turned up straight here. I now want to do the cutting plane, okay, or the true shape. Sorry, I'm talking nonsense here. Okay, so now what I have to do is I need to either make it parallel to my cutting plane, but I don't have space, okay? You guys will have space in your course drawing, so you don't have to stress about that. You will have space for that. So what I'm going to do is I'm going to draw an XY axis where my right view would have been now, okay? So I'm going to draw an XY axis here where my right view would have been. And then what I'm going to do is I'm just going to get a starting point on here. So that's where I'm going to start. So now what I'm going to do is I'm going to take my true length from that point to that point, okay? And I'm going to scribe it. And then from that point to that point, and it must be on the cut, because this is a true length. It is the distance that the exact cut gives me. So there is my distance is there, projected across. Okay, so I just want to show you what I'm saying with a true length. If I'm taking this distance that I just did, okay, it was this distance between 2 and 5 and 3 and 1. If I put my distance there, do you see that it is not exactly the same? So you see how much longer it is than the actual, it's about 2 millimeters longer. Okay, so that is why it's not a true length when you look at the cut directly from the top, especially if your solid is on an angle, okay. So now what I do is I take the view that has the cut and I use these true lengths, because this is actual true lengths, because I used my auxiliary view to get this distance. It's my length that is not true length. My width is actual true lengths. So I can take this distance from there to there, follow, okay, so it was this one. You would now, if it was parallel, follow to your XY axis and scribe. Same distance there. Scribe. Okay, and that is now my true shape, because it gives me the exact width and the exact length of my cut. So, whereas from the top view or the right view or the left view, it did not give me the exact length, but although it gave me the exact width. So that is why we are doing the true shape. And then you must also please hatch your true shape. And you must label your true shape. Okay, so those of you who have now already done this page and you want to go and practice the true shape, you will now actually see that there are space to do exactly what I did now here at the bottom. Okay, that is why we use the rule of similarity and not the 45-degree angle. Otherwise, you would have had a 45-degree angle here now and you won't be able to practice the true shape.